Hey, what's up everybody? This is the second part and the last part for my series of video about Grep regex. If you didn't see the first video, I encourage you to watch it. You can watch as well my first video about Grep, which is about all the options you can use with the Grep command. What I encourage you to do as well is to download the files which are in the description, these files, and you can try an experiment with me while watching the video to play around with Grep regex and to try really to understand what it is about. You will learn way more that way. What I advise you to do as well is to answer my question. I will ask you from time to time in the video. At that point, you can pause the video and try to answer the question. Of course, you don't have to do it, but again, it's for you to learn even more. Because unfortunately, if you only learn passively the video and you're not active, you're not learning actively, I'm afraid it will be more difficult to understand and to apply your new knowledge. Of course, if you... All right, let's dive in. Before, though, in the last video, I was speaking about grep -p, which is to use the regular expression flavors of Perl regex. And the thing is, it will work if you have GNU grep. So you can see here, I have GNU grep, and if you have a Linux-based system, it's likely you will have that. But if you use macOS, for example, you might have BSD grep, and with BSD grep, you can't use the Perl flavored regular expressions. You only can use the extended regex with -e. And in that case, if you want to do regexes with grep, you should use grep -e. All my videos about grep regex will work with grep -e anyway, so that's great. Okay, so let's dive in. First of all, how do we repeat part of a regex? With braces. Let's say I want to find lines where 3 zeros in pacman.log. I can do that. And as you can see, if I do that, I have the line with 3 zeros in it. Now you can do, I want 3 zeros or more. I don't have more than 3 zeros in my file pacman.log, but let's say I want 2 zeros or more. You can see that I have every line where the pattern 2 zeros is matched, as well as the 3 zeros and 4 zeros if it exists in your file, 5 zeros, and so on and so forth. So this notation with the comma here means 2 or more. Without the comma means exactly 2. And you can as well put a higher bound. So let's say I want 0 2 or 3 times, but not more and not less. So it's really to put a lower and a higher bound on the pattern just before the curly brace. Let's say I want to match double L in the file haskell.log. I can do this. And as you can see, every double L will be matched in haskell.log. I can only show the pattern if I use the option O. And I have many double L's, which is always super interesting to do. So let's do now some exercises. Let's say I want to match every binary number and only binary, which are maximum 1 byte. So binary composed only with 0 and 1, and 1 byte means only 8 characters in the exa file. How would I do that? Well, I can do, so I want only binary numbers, so I can do a character class saying here I want only 0 and 1 from 1 to 8 in the exa file. And here you can see I have every binary numbers, but the problem is I have part of hexadecimal numbers as well on the left, which is not very good. What I can do is saying that I want a word, like we saw in the last video. So you can use -w, like that or like that. And this time, it will work and it will only display what I want. Now let's say another exercise, so you can pause the video and try to answer it. If I want to match every hexadecimal number and only hexadecimal number in the file exa, uppercase or lowercase letters, it's not really true, from A to F. So I want to match uppercase or lowercase letter from A to F and 1 to 8 digits like the previous example. So how would I do that? Well, here's the solution. You can do grep E. So we know, if we look at the exa, that all the hexadecimal number on the left at the beginning of the line. So what I can do is at the beginning of the line, I want every letters from A to F, uppercase and lowercase, digits as well. From 1 to 8 characters in the file exa. And it will work. Here I only match the hexadecimal number. Now, if I want to be very careful and I don't want any substring, it's not the case here, but let's say if I really want to be precise, I can say I want only words, and in that case, substrings won't be included. All right, let's see now how can you match one or multiple alternatives. So let's say I want to match the word sane or pacman in pacman.log. To do so, I can do that. And here, sane word or substring will be matched as well as pacman in pacman.log. This character, in that case, the meta character, which means or. Like many other programming language, it's a logical or. So let's say now I want to match running pacman or sane in pacman.log. I can do that. And it will match running pacman or sane in pacman.log. Now, if I say that I want only the whole word pacman or sane, but running could be a substring, I can't do that because if I use the option W, everything here will be will match a word. Running will match a word and not a word or a substring. So I can use \b, and we could think, okay, if I want whole word only for pacman and sane, I could do that. If I try that, it doesn't work because you can see here, sane is still a substring in this word libk sane, And I don't want that. I want sane to be a whole word. So it doesn't work. And why it doesn't work? It's because the priority of the pipe is very low. It's the lowest you can find. And what's the priority? Let's say in arithmetic, when you do 2 plus 4 by 2, it will be equal to 10, because first you will do 4 by 2, which is 8, and then plus 2, 10. You won't do 2 by 4 first, because multiplication has a priority on addition. Well, here, the slash b has priority on the OR. So to really do what we want, you need to use a group. And to make group in regular expression, you can use parentheses. If you do that, if you group Pacman and sane, it will work, and Pacman and sane won't be a substring in your result, because this group has the highest priority. Like in mathematics, when you use parentheses, you prioritize what you want to do. So here it's the same. You want to prioritize Pacman or sane, and you say, hey, I want those two to be whole word. Let's see now how to find the magic date in pacman.log. What's a magic date? It's a date which has the last 2 digits of the year equal to the digit of the month equal to the digit of the day. This is a magic date. So how can we build a regular expression to find this magic date? Well, we can do that. First, I want to match 2 digits, which is the beginning of the date. And now I will use a group to capture the last 2 digits of the year. And I say that I want to repeat those last 2 digits, whatever it match. I want to repeat the match for the month and for the day in pacman.log. And it works. We found the magic number. So what does it mean? It means that the first group I capture here between the parentheses, the first group I capture here between the parentheses, whatever it match, I want to repeat it here and here in my regular expression. If I have 2 capture groups, let's say I have this one as well, I need to precise what I want, saying that I want a second group from my regular expression. Here, there is a first group, and here there is a second group. And I say, hey, I want to repeat the match of the second group here and here in 2 places in my regular expression. Now you can see it works as well. If I would have let the 1 here, it doesn't work anymore because I would have matched a 0. So I would have matched something like that, but it's not, is it? No, sorry. I would have matched something like that. I'm trying to match something like that, or something like that. But it's not in the file, so it doesn't find it. If we use Grep, it's a bit easier because you have access to different meta character, and you can use \d for decimal. So it's a bit easier to write, and it's clearer as well to read. If you do that, it works as well. Let's do some exercises now. In haskell.log, I want the version number with the same minor, major, minor, and patch version. What does it mean? I want to match that, or that, or that, or whatever version which has the same number before the point and after. So how can I do that? You can pause the video and try to answer the question. Here's the answer. So I want to match one digit from 0 to 9. And then I want to match a period, and I don't want to use a meta character period, but really the character period. I want to match period. Then I want to match whatever the first group is matching. Then I want a period again. Then I want again the match of the first group in in haskell.log. And here we go. All right, let's see now the quantifier. I will open here an instance of Vim just to write some stuff. So quantifiers, you can use quantifier to match one or more repetition of the preceding symbol, a bit like the braces we saw at the beginning of the video. So let's say, for example, I want to match one or more repetition of the preceding symbol or character. I can use, for example, so what I'm trying to do here is I want to match every line when there is Pacman minus or S, one or more repetition of S, which is a symbol just before the plus. If I do that, it doesn't work. And why? Because I'm using here the basic regular expression flavors of grep, because I'm not using -e. And in this mode, unfortunately, plus is not a meta character, it's considered as a character. So be careful with that. As I was saying in the first video, it's better to always use -e if you want to match a regular expression, and if you don't want to match a regular expression, use -f. And if you can, use -p, which is paired regular expression flavors, which is even better. So let's try that. And here, as you can see, it works. I'm matching -or s, and I'm matching -or ss as well. And if there were even more s behind it, it would work. In the same fashion, you can use question mark if you want to match 0 or 1 repetition of the preceding symbol. So here it works, but this time I'm matching -or without s, -or with an s, but I'm not matching -or with 2s, because question mark is only matching 1 or 0. And the last one is the star. You can use the star to match 0 or more repetition of preceding symbol. So if I do that, you can see that it will match. Oh, sorry. You can see that it will match -or, which is 0 times s, -or s, which is 1 times s, or -or ss, which is 2 times s. So to summarize, the question mark is 0 to 1 time, plus is 1 or more, and star is 0 or more. All right, let's do more exercise. Let's try, oops. Let's try to match the patterns beginning with slash, followed with slash, or digit, or letters, both uppercase and lowercase, or minus, repeated 1 or more time in the file haskell.log. So here's the solution. To do that, you need to grep -e, so a pattern beginning with slash, and then followed with slash, digits, letters, uppercase and lowercase, or minus. So it will be something like that. And I want this character class to be repeated 1 or more time. So I use a plus, and it's the file haskell.log. As you can see here, I will match every path I have in my file, which is pretty cool. Here, something you need to be aware of is this minus. If you put, oh, and I made a mistake, by the way. I forgot the slash here. Yeah, it's better. So here I'm matching every letters, uppercase and lowercase, every digit from 0 to 9, slash, and minus. You need to put the minus at the end if you want to include the character into the character class, because if you put it here, for example, it will consider the range from 9 to slash, which doesn't make any sense. That's why if you do that, invalid range end will be the error grep will output. So you always need in character class to put minus at the end. So here we match every pass in haskell.log, and you can even isolate the match to see it more clearly. And it's how you can actually easily match paths in a file, for example. Why not? All right, I want to say something very important about quantifiers. So question mark, plus, and star, they are greedy by default. And I will show you what it means. I will create a new file with hello, my name is Coco inside. So this is my new file. And let's say I do the following. What do you think it will match? So let's see. It will begin by match H, then period means any character, plus means 1 or more time, so we'll match H, 1 or more character, any character, and followed by O. So if you take the sentence here, H, any character, and O. So it should match hello, right? Wrong, it matches the whole line. Why is that? Because quantifiers are greedy. Let's put here so here our grep command, and here is our string. So what means the quantifier is greedy? We begin by h, as we said, and then it will continue to match every character, as we said, but till the end. And then at that point, it will stop and look what is after the quantifier. Let's say grep sees that it's O, so it will go backward and it will find the O in Coco, the last O, and it will stop at that point and match everything. So how to match only hello in that case? Well, you can do something like that, which is a bit of a hack. This time it works because we want to match H, every character except the space, and this, this one or more time. And it works because this will match H, E, L, L, O, and then encounter a space, and it will stop at that point because it's before the quantifier. It's really when the regex is read, when the quantifier is read, it goes till the end of the line for grep. But if you use regular expression into your programming language, it will go often till the end of the file, which means that it will go to the end of the file and then go backward. Another more better solution, but you need pair regular expressions for that. You can do exactly that what we did, but adding a question mark after your quantifier. And it works as well because here the question mark doesn't mean 0 or 1 quantifier as we saw before, but if you put a question mark just after a quantifier, it means I don't want you to be greedy, but to be careful of what's after the quantifier and stop at that point. So it will do what we wanted to do from the beginning on. So be careful with that. I mean, for grep, since grep is reading and trying to find your pattern line by line, it will only affect, the quantifier will continue till the end of the line. But as I was saying, if you use that in many programming languages, the regular expression will go till the end of whatever file you're parsing, or output, or whatever. All right, that's all for today. If you have questions, don't hesitate to let me a comment. I hope you find this video useful, and see you next time.